Hi, and welcome to another episode of Mr. Avila Physics. Today we're going to be discussing forces and equilibrium. As we discussed in a previous video, a force is defined as a push or a pull resulting from an object's interaction with another object. When that interaction stops, then the objects stop experiencing a force. Okay? Now, these forces can be described as contact forces or forces at a distance. So, a contact force occurs when the objects are actually in contact with each other, and that's when the force occurs. Forces at a distance do not need to be in contact with each other. So, contact forces include friction force, tension force, normal force, air resistance, applied force, spring force, etc. And forces at a distance include gravitational force, electric force, magnetic force, etc. Okay? Throughout this course, we're going to be discussing most of these forces at some point or another. Alright, so a force is a vector quantity. Therefore, it has a magnitude and it has a direction. The units for force is the Newton. 1 Newton is defined as the amount of force required to accelerate a 1 kilogram mass at 1 meters per second squared. So we can say that 1 Newton is equal to 1 kilogram times meters per second squared. Alright, forces and net force. Sometimes there are more than one force being applied to an object, and the net force is defined as the sum of all the forces acting on an object. For example, if I wanted to find the net force on this object, then I would add all the vectors here. So I would add the vertical vectors. I would say, alright, so plus 40, and then I would have here minus 40. That would give me a net vector of 0 newtons in the vertical. And if I look at the horizontal forces, I would have a plus 30, right, to the right, remember, is positive. And then I would have minus 30 because it's to the left. So if I add 30 plus negative 30, I also get 0 newtons. So the net force on this object is 0 newtons. Right? Now, let's take a look at another example. Let's take a look at this one. So in this example, there are no vertical forces. But horizontally, I have plus 30, and then I have minus 10. So if I add these two vectors, a vector of plus 30 plus a vector of minus 10, I would get an answer of plus 20. So my net force would be 20 newtons to the right or plus 20 newtons. Okay. Alright, now try these examples on your own. Pause the video here, take a couple of minutes and see if you can solve these examples. Alright, welcome back. Let's look at our first example here. So, as we can see, this object has vertical and horizontal forces being applied to it. So, let's look at the vertical forces. So, vertical forces, I have a plus 3, and then I have a minus 3. So, my vertical net force is 0 newtons. Horizontally, I have a 16 Newton force to the right and a 5 Newton force to the left. So this gives me a net force of 11 newtons to the right, or positive 11. Now let's look at this next Let's look at this next example. Okay, so in this next example, vertically, I have a plus 12 and I have a minus 15. So vertically I have a net force of minus 3 newtons. Now horizontal, let's see what we have. Horizontal, I have a force of 16 newtons to the right, and then I have a minus 7, and minus 2. So horizontally my net force is 0 newtons. So my total net force for this example would be minus 3 newtons or 3 newtons down. Remember that since force is a vector quantity, you need to give both its magnitude and direction. Alright, let's look at this next example here. Pause the video here, take a couple of minutes and see if you can answer this example. Alright, welcome back. Now as we can see, this object has vertical and horizontal forces on it, so let's look at the vertical forces. Vertical forces, I have a plus 6 and I have a minus 7, so my vertical net force is 1 newton down. Horizontal, I have a 5 newtons to the right, positive, and a 2 newtons to the left, so I end up with a net force of 3 newtons to the right. So after first combining the vertical and horizontal forces, I see that my object has a 1 newton force, okay, and it has a 3 newton force in this direction. The arrow already indicates the direction, so there's no need to put the negative sign. So how do I add these two vectors? Well, simple. I simply draw the first vector, and then at the end of the first vector I draw the second vector. And my net force would be the vector connecting the beginning of the first vector to the end of the last vector. So that would be my net force. And since this is a right triangle, I can use Pythagorean theorem to solve this. So my net force would be equal to, okay, the square root of 10 newtons. Now, what about the direction? Well, for the direction I use trigonometry, and I will use the inverse function of tangent. So inverse tangent of opposite over hypotenuse, and this gives me an answer of, let me get the calculator, okay, inverse tangent, this gives me an answer of 18.4 degrees. So my net force is square root of 10 newtons in a direction of 18.4 degrees. Alright. Now let's talk about forces and equilibrium. There is a combination of forces that allows an object to be in equilibrium. And this happens if and only if the net force acting on an object is 0. This is also known as balanced forces. Okay, so if the net force is 0, then all the forces acting on an object are balanced. If the net force is different than 0, then we would have unbalanced forces. So when an object is in equilibrium, there are no changes in its state of motion. Remember in a previous video about Newton's first law, we said that an object will remain in its current state of motion unless acted upon by an unbalanced force. This is the unbalanced force, a net force. Okay? So, state of equilibrium is if the net force is 0. So, when an object is in equilibrium, the forces are balanced, which means that the object is either at rest or moving with constant velocity. And since the forces are balanced, then the object will either remain at rest or stay in motion with the same speed and the same direction. For example, here, in this example, the forces acting on these physics books are balanced. Gravity pulls downwards on the book, and the table pushes upwards on the book with the same magnitude but in opposite directions. So these two forces balance each other out. So the book is said to be at equilibrium. Alright, let's try one example. An object is in equilibrium. It's suspended by two strings from points A and B as shown. Find the tension in each string if the force applies a force of 490 newtons downwards. Tension is the force that is on a string. So if a string is taut, it has tension. If a string is all loose, then there is no tension. Alright, pause the video here, take a couple of minutes, and see if you can answer this example. Alright, welcome back. So let's take a look at this example here. So what we have here is a, pardon my non-straight lines. So we have something like this. Now, if I look at this point right here and see the forces acting on this point, I'm gonna see a force acting in this direction called tension A. I'm gonna see a force acting in this direction called tension B. And I'm gonna see a downward force called weight, which is equal to 490 newtons. Now, I also know that the angle that these two forces make with the horizontal is 40 degrees. So, since I know that this object is in equilibrium, then I know that the sum of the forces in X, or the net force horizontal, is going to be equal to 0. Now, how many horizontal forces do we have? Well, we have, I'm going to see if I can change the color of the pen. Yes, alright. So, we have two horizontal forces. We have the horizontal component of this tension A, and we have the horizontal component of this tension B. So then I will know that tension AX minus tension BX is going to be equal to 0. I know that tension AX is going to be equal to tension BX. Now, how do I find tension AX with trigonometry? So this becomes tension A cosine of 40 degrees equals tension B cosine of 40 degrees. And this tells me something very important. It tells me that tension A and tension B are equal. I don't know its value yet, but I know that they're equal. So now let's look vertical. Now I know that this net force in Y is also 0. because this object is in equilibrium. So how many vertical forces do I have? Well, I would have the vertical component of tension A, I would have the vertical component of tension B, and I would have the downward force of weight. So that means that when I apply this formula, I know that tension By plus tension Ay minus W has to be equal to 0. So tension By plus tension Ay has to be equal to W. Tension B sine 40 plus tension A sine 40 has to be equal to 490. Now I know that tension A and tension B are the same, so 2 tension A sine 40 is equal to 490, which means that tension A, which is equal to tension B, is equal to, take out my calculator here and get that 490 divided by 2 times sine of 40. This gives me a tension of 381.15 newtons. And since the problem is asking for the magnitude, then that is the magnitude of our tensions. Alright, this problem is a little bit more complicated, but hopefully it makes sense. So when an object is in equilibrium or not in equilibrium, we always have to analyze its horizontal and its vertical components separately, that's why we worked horizontal first and then vertical. Okay. All right. So thank you all for watching, and I'll see you on our next episode.